Assalamu alaikum. Hello everybody. Today we're gonna take the second experiment, which is hardness experiment, or we can call it a perennial hardness test. The main object of this experiment is just demonstrate measurement of hardness of metallic materials. Just to know which the material is harder than the other. So we have three materials here, and we gonna work with them, such as those low carbon steel. Here high carbon steel, and here we have the brass. We just try to affect each one here, such as low carbon steel. If you notice that the low carbon steel and high carbon steel, we have two different types. If you see here, the grain or the surface is not clear because we do the heat treatment for the low carbon steel and high carbon steel. So the heat treatment should to be like make it harder, because it will affect the atoms inside the steel. Then it will organize again, so it will be should it to be harder than before. So this one is harder than this one. That's what it should, and this one is harder than this one. So far we just will put the sample here, and we have to know here the load. See, here is load. When I do it here like this one, it will should to be to unload. So I will change it from 100 to 150, or I can keep it 100 and work it with 100. So what we have in here, just to affect on this material with 100 kilogram. Actually, it's not Newton, it's kilogram. Why? Because that's what we got from the manual of this machine. Here it's 150 kilograms. Actually, it's supposed 150 Newton. If we're gonna work with the equations, it should to be 150 or 100 Newton. So far, I will add the load here. After that, it will be effect on the. Let us try first. If you can see here, see the load. See, now it's already unloaded. So let's try to take the material and see the notch that it's having here. If you can see here, this is the notch, and to measure it, we have to take it here under the microscoping. This microscope, it has a ruler inside the lens, which is gonna let us just measure the diameter of this sketch or scratch. So that's how we gonna work with this experiment, and I will do it for three materials. I will work with low carbon steel and high carbon steel and brass. Next experiment is gonna be same, but just for heat treatment. For low carbon steel heat treatment and high carbon steel after heat treatment. To be clear, we have for the lab work, we have force used. For all of them, we're gonna work with 150 Newton or 150 Newton. So the indentar diameter, it's gonna be 10 millimeter. The indentar diameter, it should to be this one. There is a pole here. I'm not sure if it's gonna be clear or not. If you can see it, yeah, there is a ball here. This one is the diameter of it, it's 10 millimeter. So for all of them, 100 Newton, 150 Newton, and 10 millimeter for indented diameter. The difference between them, it's gonna be for measured diameter. The measured diameter that we will take it, it's supposed to be this scratch, like the diameter of this scratch, as I told you, this scratch. Then I have to multiply it with 0.2 to get the measured diameter. Why we have to multiply it with 0.2, I have no idea, because just that we take it from the catalog of this machine. Maybe it's convert units, I'm not sure, just to be in millimeter. So it's 5, like if we found this scratch diameter is 5, so it's gonna be 5 times 0.2 millimeter, it will be 1 millimeter. The Brinell hardness number and indent depth, it will be from the equation that we have in the lab report. The tensile strength, we will take it from the graph that we have it for the second page between the Brinell hardness number and tensile strength. We have already the number of Brinell hardness number. Let us check it here. So, such as if we found it as a 100 or 200, we have to go up to the steel line, and when we just across with the steel line, we will take the number here in megapascal. So this one, it will be just for the steel, and we're gonna do that again with the brass. That's all for our experiment today. Thank you for watching.